Hello, who is Ganesh Kumar? Okay, Robikant 136.
Yes, sir.
Yeah, Robikant 136. Sodhanjali, your roll number?
So 145.
145. Then Shambhu Singh?
Sir,
142, sir.
142. Ashwini Jadhav 123, right?
Yes, sir.
Okay. Then Gavin Chand
Present, sir. 127.
127. Sarvesh Kumar 137.
137.
Okay. Let me check. Avinash Kumar 165, right?
Yes, sir.
Ayush Kumar.
No,
Ayush Kumar
124. 124.
Okay. Ganesh Kumar. Ganesh Kumar, I don't know. Then Shoshi Maria. Sakshi Maria.
Yes, sir. 180.
Sakshi. Then Shayan
Yes, sir, 182.
182. Shubham
Yes, sir. PHY 094.
194.
Yes, sir.
Okay. Somadip Mukherjee
150.
150. Then Shubhangshu
148, sir.
Okay. Shukendra
097. PHY 097.
97 is okay. 097 is not needed. Then Sukhendra Utkal
The PHY 103.
103. Vijendra Kumar
PHY 188.
188. And Bimal Jadhav
108.
108. सेवेंटीन स्टूडेंट और कोई बचा है इसमें?
One.
Yes, sir. Avinash Kumar, PHY 192.
अविनाश कुमार को पूछा था ना? आयुष
सर वो एक और
अच्छा,
है.
अच्छा दो अविनाश कुमार 192. और कोई?
Yes, sir.
और कोई बचा है? Okay, so let us start the class tomorrow. गणेश 3 बार बुलाया तुमको, क्या रोल नंबर है? गणेश कुमार अभी चौथा बार बुला रहा है, इसका
126.
हाँ तो
120.
आप जब ऑनलाइन है ना तो क्लास सुनो, और नहीं तो छोड़ के भाग जाओ, कहीं और काम है ना तुम्हारा तो वो काम करो.
094 सर हुआ है ना हमारा शुभम कुमार PHY
नेटवर्क
094.
इशू है इसलिए नहीं जा रहा है.
तो नेटवर्क नहीं होगा तो ऑनलाइन इस बार ड्रॉप कर दीजिए ना. नेक्स्ट बार जब 5G आ जाएगा तब नेटवर्क ज्वाइन करो. हम क्या करें बताओ? तुमको BHU आना है, BHU आके यूनिवर्सिटी का नेटवर्क यूज कर. हाँ तो नहीं होगा तो अगर सुनाई नहीं दे रहा है तो बेकार आप टाइम बर्बाद कर रहा है, क्लास छोड़ के जाओ. जैसे तुम्हारा क्लास में 70 लड़का है, अभी 20 लड़का प्रेजेंट है, तो तुम भी क्यों यहाँ परेशान हो रहा है? सुनाई नहीं देगा.
सरकार
क्या बताया लास्ट वाला 10?
कभी कभी
हेलो, कोई और?
ऐसा होता है हमेशा.
तो PHY 094 शुभम कुमार.
094 नहीं होगा. ठीक है, चलो और किसी का नहीं पूछना है. 10 मिनट हो गए. 094 ठीक. चल, कल हम लोग का एग्जाम है 12 बजे से और उसका बाद 12 से एक एग्जाम है। और सिलेबस आप लोग का कोई बच्चों अभी सिलेबस पूछ रहा है, सिलेबस क्लास में बताया गया है। तो आई हैव मेंशन मेनी टाइम्स सिलेबस अप टू द मैकेनिकल सिमिलरिटी or before the virial theorem. This is your syllabus. Okay, so be careful about the syllabus, and there will be some instruction for your exam. ऐसे नहीं है कि हर बार जैसे ओपन बुक एग्जाम होता है एक ही टाइप का होगा. There will be some instruction. So my suggestion is that first read the instruction carefully. जैसे आपका मेल में आंसर भेजना है तो मेल में सब्जेक्ट लाइन में आपका रोल नंबर लिखना जरूरी है. और कुछ अगर लिखना है तो इंस्ट्रक्शन में बताया दिया जाएगा कि और कुछ भी हो सकता है उसमें, लेकिन रोल नंबर हर का लिखना जरूरी है सब्जेक्ट लाइन में. जब मेल भेजोगे तो हमको मेल में सब चेक करना है तो रोल नंबर वाइज देखना है. तो उसका और कॉपी अगर हम मिल जाएगा दोनों बच्चों को, हमको हमारा हिसाब से अगर कॉपी लगेगा तो दोनों पेनलाइज होगा. दोनों क्या, अगर मान लीजिए एक ही क्वेश्चन कॉपीड है चारों बच्चों 10 बच्चों, तो 10 को सेम इक्वली पनिशमेंट मिलेगा. 0 मिलेगा तो 10 को 0 मिलेगा, 5 में 2 मिलेगा तो सबको 2 मिलेगा. तो जब आप लोग अपना क्वेश्चन व्हाट्सएप में दूसरे बच्चों को लिए शेयर कर रहे हैं ना, थोड़ा ध्यान दीजिए कि दूसरा बच्चा वही कॉपी कर देगा जो आपका पास कॉपीड है. और हम ये जो कॉपीड पकड़ने के लिए हमारा बहुत एक्सपर्टाइज है. ये आप लोग थोड़ा ध्यान दीजिए. सो माय सजेशन इज दैट कॉपी मत करिए. आप अपना डिस्कशन कर सकता, लेकिन व्हाट्सएप में अपना आंसर यू कैन नॉट गिव योर आंसर इन व्हाट्सएप ग्रुप सच दैट आज ये 22 बच्चों है, कल 70 बच्चे आ जाएगा, सबका मार्क्स मिल जाएगा, है ना. और क्वेश्चन तो आपको अनसीन क्वेश्चन मिलेगा. दैट इज फॉर श्योर. फ्रॉम माय पार्ट यू विल सी अनसीन क्वेश्चन जो आपको असाइनमेंट सीट में भी नहीं है, किताब में भी नहीं है, तो करना पड़ेगा. Now some good student will do and they will share it to the group. That I'll try to stop it. And वो पकड़ जाएगा तो जो शेयर किया है उसको भी पेनलाइज होगा और जो कॉपी किया है उसको भी पेनलाइज होगा. और ऐसा मत सोचिए कि हम नहीं जानते हैं. स्टूडेंट में भी बहुत हमारा एजेंट है जो हमको बता देगा कोई आपको कौन ग्रुप में दिया है, कौन आंसर दिया है. बहुत सारे स्टूडेंट है जो हमको बता देगा क्या है इसमें. Anyhow, so let us continue with that. Last time we were stopping. Do you have any question on the last time? We discussed the D'Alembert's principle, and from there we obtain equation of motion. So from there we'll start our today's class, and probably Dr. Krista may take 2 classes from next week or after Deepavali. That I don't know. I'll talk to him. He may now take 2 classes. Huh.
Sir, sir, last day I asked you one thing. If a force is acting on a body, then how would we write the Lagrangian for that?
So then you have to know that how potential can be found for that force.
Sir, suppose there is a block placed on the ground. I pull it with a force, and
What
there is
is
also
that
frictional
force?
force acting.
What is that force?
Sir,
That you have...
sir, a constant horizontal force is being applied by me to the block, and also the friction is there. So how would we write the potential in that case?
Friction, right now you cannot write a Lagrangian for a friction. That I'll teach separately. That if you have a dissipation system, then the friction potential is velocity dependent, right? So friction depends on the potential depends on the velocity, and velocity dependent potential so far we have not learned. Only in D'Alembert's principle we know that there is a particular way of velocity dependent, then I can write the Lagrangian, and that particular way was this way. Let me show you. This is old last time note. This is that conservative case 1, case 2, where potential, this is force and this is potential. If they are related, potential is velocity dependent, but in this fashion you can obtain the force. So when you are saying there is a block, you are applying a force, you must have know the potential to obtain that force. Otherwise you cannot write the Lagrangian. But frictional force, viscosity, that kind of force, I'll discuss later, that they can be handled by modifying the Lagrangian. So that I have not taught you, I'll teach you later. First, electromagnetic field, when charged particle in the magnetic field, potential is velocity dependent, and in this type. That first we'll learn, and then other potential, velocity dependent potential we'll study. Okay. Okay, so this is the type which is very important for you, that this is the, if there is a velocity dependent potential and force can be obtained through this particular relation, then we'll able to find the Lagrangian. And that case also, the Euler-Lagrangian equation and D'Alembert's equation will have the same form. But if the force is not obtainable from potential, like other cases, frictional case can be dealt differently, then this will be the equation of motion. This is the force, this is the kinetic energy derivative, and this is kinetic energy. Then this will be the equation of motion when the force is not known in terms of potential. And Lagrangian does not exist because you don't know potential energy. So that case you have to deal with only kinetic energy and then equation of motion. So now let us consider the magnetic field case, which is very, very extremely important. And you know, magnetic, if you have a charged particle in the magnetic field, the charge Q, or maybe let me write capital Q, because Q we are writing coordinate. So capital Q is the charge, M is the mass, and magnetic field B, electric field E. So in this, you know, the charged particle in the electromagnetic field, you can deal with two ways. You can study motion of charged particle in the electromagnetic field in two ways. One is through the finding the Lorentz force. Lorentz force is Q time, no, this is capital Q. Q charge times electric field plus if the velocity of the particle is v, then v cross b by c. This c, I'll talk about if electromagnetic. When you study the particle in electromagnetic, you have to fix your unit, Gaussian unit or SI unit, right? So in depending on the unit, sometimes you will find C, sometimes there will not be C. So I suggest that look at the standard book like say Halliday-Resnick to find that which unit you are writing. Okay, so I'll prefer this form of Lorentz force. I don't recall exactly. I think this is Gaussian unit, but verify it. So either you find this force and then find the dynamics. So this is the force. So you know the force, from here you find dynamics. This is one way. Other way is the through Maxwell equation. So two ways. First this, then second one is the through. I'm not saying they are equivalent. Maxwell equation. They have advantage, disadvantage. In Maxwell equation is the best way to study electromagnetism. So there are four Maxwell equations that you are familiar. So four equation satisfying by the charge, if you have a charged particle, then the electric and magnetic field will satisfy 4 different equations. So let me write, this is this is the same unit I am using, where you will have, say, the same unit will have 4 pi rho, in some other it will have only rho. Okay, so I will be consistent in one unit. Divergence B will be 0, then curl of E will assume in the free space. So let me write both electric field E. So only in the free space. So and then this plus 1 by C del B del T equal to 0. And then you have curl of B equal to 4 pi by C j 1 over C del E del T, right? I'm correct? Yeah, I think so. This is called charge density. And this is current, right? Current density. So these are the 4 Maxwell equations, and these equations are very important for physics, of course, and also for different interviews and other places. Questions generally asked from always asked from Maxwell equations. So you should know how to write Maxwell equation in free space, how to write Maxwell equation without charges, free charges, Maxwell equation in dielectrics, Maxwell equations in different medium, kind of thing. 2 important thing I'll tell you here. One is that generally you have heard this statement that the light is electromagnetic wave. Maxwell equation says that light is electromagnetic wave, and it's has 2 degrees of freedom. And those are transverse degrees of freedom. 2 transverse degrees of freedom. This is statement, you know, I'm not going to explain all this, but 2 transverse degrees of freedom. So if light propagate in this direction, there will be a suppose this is z direction, this is direction of propagation, then there will be electric field and magnetic field will be perpendicular to this direction of propagation, that you know. So these are the 2 degrees of freedom, that it has 2 components. Only one component is perpendicular to the direction of propagation, which is called electric field. Another component will be perpendicular to both electric field and the direction of propagation. So electric field, magnetic field are direction propagation mutually perpendicular. Okay. So 2 degrees of freedom, but how these 2 degrees of freedom are coming, that is very easy to understand from this. So let me tell you that. See, electric field E has 3 components: Ex, Ey, Ez. Similarly, magnetic field. So 3 components, and components can be any arbitrary number. For an arbitrary electric field, you can have for a particular electric field there will be particular number, but in general electric field you will have 3. So electric field has 3 degrees of freedom because it has 3 components. Magnetic field also has 3 degrees of freedom. So total electromagnetic field, EM fields, has 6 degrees of freedom. Okay, 3 from magnetic field, 3 from electric field. Okay. Now still, when light is electromagnetic wave, and when light propagates, it says that it has only 2 degrees of freedom. So this question was asked many times to the student, how this happens. Light should have 6 degrees of freedom, but that is not. Okay, so that can be very easily explained from Maxwell equation. So this equation, there are two equations which is inhomogeneous. This equation and this equation, they are inhomogeneous. Inhomogeneous means right hand side is not 0, right? Right hand side we have the current density or the charge density. Okay, so these equations, these two equations, equation 1 and 4th in this situation are defining equation for E and B. That means if you have a charge density or charge, then electric field is defined. If you have a current, then that will define the magnetic field. So this row will decide what will be the electric field. So this is the definition of electric field. Defining equation. And similarly this magnetic field. Okay, but these two equation is the constraint. So equation 2 and 3 are constraints on E and B. So we have to see how many constants are there, then we can find degrees of freedom. So this has only one constraint. Why? Because this is only one equation. Right hand side is a number, left hand side is also a number. So this is only one equation. But this equation is a vector equation. So I can write x component one equation, I can write y component another equation, I can write z component. So this gives 3 degrees of freedom, 3 constants. So this first equation is 1 constant, second equation is 3 constant, so 4 constants. So total constants equal to 4. So remaining 6 minus 4 is the 2 degrees of freedom. So that light has 2 degrees of freedom only because from this explanation is coming from this. Okay. Also, from these equations and little bit knowledge of solution, you can find how this electric field and magnetic field is perpendicular to the direction of propagation. I'm not going to do, you are studying electromagnetic theory, they will explain in details. Okay. So now our job is that we wrote a Lorentz force. Now what will be the potential? Now my question is that what is the potential? What is the potential which gives this force? We know this force is coming from the electric and magnetic field, but what will be the potential? If we can find the potential, then we can find the Lagrangian. Okay, so that is our job today. In next 30 minutes we'll try to find that potential. But potential, how you will find the potential? First let me write the potential from Maxwell equation. Okay, so let me erase because I don't want to write Maxwell equation again. So let me erase this part. Okay, so you all know that if some divergence of some quantity is 0, then that quantity has solution, its curl of some quantity, right? Because divergence of curl will be 0. This is a vector identity, all familiar. Divergence of curl of a quantity, always 0. So this vector identity is, so if I have B equal to curl A, then this will satisfy, and this A is called vector potential. It is a vector, it is a potential because field is obtained from here through derivatives. So this is a vector potential. Okay, so this everybody knows. Now I'll substitute this in the second equation. So curl of E plus, what is this, 1 over C I wrote, no? 1 over C del B, so B del T B, I'll write curl of A. This is a curl, this is a curl that I can common take. Okay, so this curl of, I can write E plus 1 over C del A del T equal to 0. Now, if a curl of a quantity is 0, then that quantity also can be written in terms gradient of something. So, E plus 1 over C del A del T can be written as gradient of some quantity. Let me write phi. I use a minus sign, but that is right now purely has no meaning, no reason to write a minus sign. If you write a plus sign, then also this satisfies, because this gradient of curl, curl of a gradient. So, curl of gradient is always 0. This is again a vector identity you have proved. If you have not proved, then you prove yourself. Okay, minus sign is just to match that you have when you write force conservative system del u del x minus del u del x. So, this gradient is also like derivative. So, we should expect this field is like a force. So, so it should be minus. So, keeping that to be consistent, we put a minus sign. Okay. If you don't put, then this phi will have a different meaning. It will be negative of the actual scalar potential. Okay. This phi is called scalar potential. Mathematically, you can write minus plus, but physical argument it should be minus. Great. So, we have two potential. One is vector potential, another is scalar potential, and you can write the equation, Maxwell equation or Lorentz force, Maxwell equations, that other two, equation 1 and 2. I use only 2 and 3. So, equation 1 and 2 can be written in terms of potential. Also, Lorentz force F can also be written in terms of potential. So, that we have to see. Okay. But before I going to do that, so the calculating force in terms of potential, I want to say something about a very important properties of this potential, which is called gauge transformation. Gauge transformation of electromagnetic potentials. Okay. So, if you look at that, B equal to curl of A. If you look at this, now say if I say that A prime equal to A plus grad of lambda. So, what will happen to the magnetic field? So, let us calculate the magnetic field A prime. So, magnetic field B prime will be curl of A prime. So, curl of A plus gradient of lambda. So, curl of A will give you B and curl of gradient is 0. So, B prime equal to B. So, there is not one potential which gives this magnetic field, but there are many potential. So, this implies that there are many vector potential which gives same magnetic field. Okay, because this lambda is arbitrary. So, I can have this lambda, I can choose any lambda. I can choose infinitely many lambda, and I can have infinitely many vector potential. So field is 1, and this side you have the potential a prime, a double prime, infinitely many depending on different lambda. So one field corresponding to many potential. Those potential are related by this transformation, a prime going to a plus delta lambda. So this is called gauge transformation. Gauge transformation means physical quantity remains same, right? And the potential is different, or potential have a transformation between themselves. So that transformation is gauge transformation. So this is a gauge transformation for the vector potential. So similar thing we can also find that in case of electric field also, right? So electric field, scalar potential also. So electric field E equal to minus grad phi minus 1 over C del B del A, I think, not B, let me see, del A del T. And you can verify yourself that phi prime equal to phi minus 1 over C del lambda del T, the same lambda. Then E prime, if you calculate, let us calculate E prime. E prime will be, I am using this, so and your A prime is A plus grad of lambda. So your E prime will be minus grad phi prime minus 1 over C minus or plus, I'll check, yeah, del phi prime del lambda phi minus del y del lambda. So this is, I'm sorry, yeah, I'm little bit in hurry. So E prime should be equal to minus grad phi prime minus 1 over C del A prime del T, right? E prime. So let us calculate this E prime. E prime will be minus gradient phi minus 1 over C del lambda del T minus 1 over C del T A plus lambda. This term and this term will get cancelled, and you will find this is minus minus plus, this is minus. So this term and this term, they will cancel, and you will get E prime equal to E. So what I have found, that we have one side we have electric field and magnetic field, other side corresponds to a set of A and phi, and A prime equal to A plus gradient of lambda, and phi prime is phi minus 1 over C del lambda del T. So this, so you have infinitely many potential A and phi will give to the same magnetic field, and this transformation is known as gauge transformation. This is very, very important in your higher physics MSc, and you'll find the importance of gauge symmetry, gauge transformation. You'll learn much more details. Okay, so things are clear with the gauge transformation.
Yes, sir.
Okay, so so which approach you will prefer? In one side there is a unique, only one value of electric field and one value of magnetic field. Another side you have infinitely many A and phi. But I said there are two approaches. One approach is the field approach. This is field approach, and this approach is called as potential approach. So which approach you will follow to study your electromagnetism, to study theory of electromagnetic, which approach you will study, field approach or potential approach, or which is more fundamental?
Field.
Okay, so you are saying field because it is a unique, right? So it is field. Anybody else?
Sir, potential.
Okay, so there are another option, potential. So why potential? You think it will be
Sir, because it is scalar, so it will be easy for calculations.
no. Where A is not a scalar, no? A is a vector. A is vector, one is vector, one is scalar. Potential in your mechanics, you find that it is a scalar. Gradient is a vector, so it will come vector. But here in the electromagnetic, potential is also vector. So your argument in that sense is not correct. Okay, both are equivalent approach. You should get the same physics, same information, either you approach field or potential. But in the physics, people prefer this approach, potential approach. This is preferable. I'll explain. So this is theoretical physics people prefer this. Why? Okay, I can explain with a very good analogy. Suppose you are invited for a dinner, some party or somewhere. There are two halls. Now Abhishek Singh is coming at end of the class. What else he'll do here? Abhishek Kumar Singh. Okay. So this there are two places. One is this side, field side, or two dining spaces. So D1 and D2. In one side, you have only two menus. Either you take rice or rice dal or puri sabji. That's all. One is electric field, another is magnetic field. And this side you have infinitely different menus, and you can. So which hall you will go to have your dinner? Naturally, this hall, right? Because you have lot of option. Theoretical physics. Now, where option will help? Option will help that, okay, I can choose my potential. There are infinitely many, but I can choose my potential such that my calculations are simple. There are infinitely many. When I consider example of Lagrangian, I'll show you 3-4 example, but there are infinitely many potential. I'll choose that potential which is easier for calculation. So I have that freedom. I don't have that freedom in this side. Either I have to eat rice, dal or puri sabji. That's all. But this side, what suits you, what you like, you can eat. So that this means that potential, we have lot of freedom to simplify our studies, calculations. So this is preferable in that sense. Of course, this is mathematical. These quantities are mathematical. At least up to 1956, this was believed that these are only mathematical, no physical consequence. Because if there is a physical consequence, then how many infinitely many different physical consequences, right? So how they will converge to only one concept? Okay, so these were believed to be mathematical, but later in 1956, it was proved that they can give rise to physical consequence. So that is called Bohm effect. That vector potential, the electromagnetic potential, can give rise also physical effect. This is not a topic of this course, so I'll not teach. When I used to teach the modern physics, this I used to teach. This is a very, very interesting topic, and those who are interested, you should learn this. What is meaning of Bohm-Aharonov effect? Okay, so this, okay, our discussion on gauge theory is up to that we'll prefer in the potential approach, and you know, in the potential it is easier to write Lagrangian, all sorts of things. Okay, So now let us go to the low range force and what will happen to that. Low range force, I wrote Q E plus V cross B times C. So this was my low range force, and we want to write in terms of potential, and for simplicity let us consider only X component. Other component will generalize. X component will be Fx will be Q times Ex plus V cross B by C X component, right? So V cross B, V cross B X component, it means V Y B Z minus V Z B Y. So let me write Q Ex, I can write minus del phi del x. Remember, E is your minus grad phi minus 1 over C del A del T, okay, minus 1 over C del A x del T. So this is very simple to write component, and that side I'll write it is 1 over C, but V is Vy, so Vy is basically y dot. Let me write in terms of dot Vz minus Z dot By. But I have to I have to write the B is now curl of A. So we have to find what is Bz and By. Okay, so let me, please do follow with me because I may do mistakes. So Z component of this quantity will be Z means Ijk, and then the Z component will be okay. So del A y del A x minus del A x del y, right? If I do mistake, then I'll not get the result. So Bz, please follow. These are you all familiar. Curl you have to calculate, and this is y component. Y component will be del z minus z x minus del x of a z, right? So substitute this here. So we are calculating. Let me go to a different color. So you are calculating Fx. Fx will be Q is sitting outside, and then you have del phi del x 1 over C del A x del T, and then 1 over C, let me write these two inside here. So y dot with Bz, so y dot del A y del x plus y dot minus this minus del A x del y, then minus z dot by has del A x del z plus del dot del A x del x. Good. So this is my Fx, the low range Z component of the low range force. Okay. Now remember, I want to have this in terms of the potential. Now it is completely potential, but whether it is of this form or not, that we have to check. Whether in the case 2, whether we have to come in this form or not. So that is our check. If it is come in this form, we will find U, and immediately we find the Lagrangian of the system. Okay. Good. So for that, to check that, we need to calculate a quantity d ax dt. All the potential are function of x, y, z and t, okay, in general. So ax is also function of x, y, z and t. So if I have a total derivative, so let me write 1 over c also for my later use. So first will be it is 1 over c del ax del t, partial differentiation rule. Then 1 over c, I'll differentiate with respect to x, and then x will be differentiated with respect to t. So x dot del ax x plus y dot del a y del a x. I'm sorry, I'm differentiating only x, no? So this is x y plus z dot del a x del z. Okay. Now this quantity I'll substitute here in this equation. So let me see fx, how much time I have? 6 minutes. I'll able to finish. Fx is q. Now if I write minus del phi del x is there, then I'm substituting this. This means minus of this. So if come this side, so this will come, all these will be plus, right? This, if I bring this side, will have a minus sign, and I'm there substituting that. So minus 1 over c del ax del t, it will be there, but these terms will be plus 1 over c x dot del ax del x plus y dot del ax del y plus z dot del ax del z. Okay. Then there will be this term 1 over c y dot del a y del x minus y dot del a x del y minus z dot del a x del z plus z dot del a x del x. Now there will be cancellation. So let me see what are the terms will be cancelled. I will have x dot with x, so this term must be cancelling. Y dot del ax del y dot del ax del y. So this is with the plus sign, this is with the minus sign. So this term and this term get cancelled. Similarly, this term, let me write with, or let me use red pen. So this term will cancel with this term. Z dot del ax del z, z dot, this is minus, this is plus. Okay. So after cancelling these 4 terms, so what are the terms? Let me write q.
So last term will be del az by del x.
Last term will be del az. Which last term? This term?
Yes, sir.
This I am substituting from. So here there is a mistake. So it will be x. So it will be z. Good. So it will be z. Make this correction. So I'm when I copied from here to here, I do mistake. So it okay. So good. So del phi del x, then 1 over c d dt of a x, then I'll remaining with 1 over c, you will see v dot a term. You see v dot a means x dot del ax del x. So this term v dot a v dot v dot
Gradient of A.
yeah, del x of that. This term is del x of v dot a. Let me explain how. See, I have remaining with x dot del ax del x plus y dot del a y del y. So these terms I have remaining. These terms y with x, this term I have remaining, this term and this term, plus z dot del a x, no, del z del x. No.
So V dot gradient A.
No, it will be x v dot a and del x. It will be, velocities are constant, so it will not be differentiated. So just here I think I did mistake. X del x, y dot, z del z I am expecting. So this term, so let me go back where I did mistake. This z dot a z del x. Okay, so this term a z x. Okay, so fine. So a z, this is also x, no? This remaining term, this should be x. Yeah, this a y x, a y x. So this is my first, second term. This is my first term. This is first term. This is second term. This is third term. So if this you can write del x, all are x derivative, x derivative, x derivative, x derivative. So x of v dot a. So that I write del x of v dot a. Okay, we go through. Is my calculations are errorless? Nowhere any serious conceptual error. Writing mistake I may have, but I want to finish in 2 minutes. So this will be, this fx will be q times minus del phi del x minus 1 over c dt of ax plus 1 over c del x of v dot a, which I can write q times del x I take common here. So del minus del x of phi minus 1 over c v dot a plus ddt of phi minus phi minus 1 over c v dot a. I'll explain the second term. Okay, this phi, phi is taken to be okay, v dot a. If I have v dot a, what will have? I'll have, this is minus is matching. So this v dot a means vx ax plus vy ay plus vz az, right? Now I am differentiating, no, this is, that is why I have problem. Yeah, times ddt of del vx. Okay, I'm what I'm doing, this term can be written as this. I'm explaining that. So if you have del vx of this term, you will have ax. This is 0, this is 0. So this will give you only ax. So from this term, you will get minus 1 over c dax dt if I take this term. And phi is independent of vx, velocity. So that will be give you 0. So this term will give you this term and this. So what happened that I can write a potential u which is phi minus 1 over c v dot a, velocity dependent potential, such that my fx is now, okay, I can write a potential q times q I'll write here, this q I will say. Then this fx is del u del x minus plus ddt of del L del x dot or x dot of u. X dot is your Vx here. So this is exactly same form of the case 2 that I wrote you after the D'Alembert's principle, the case 2. So for a charged particle in the electromagnetic field, U is Q times phi minus 1 over C V dot A. So your Lagrangian will be T minus Q phi minus 1 over C V dot A. So this will be the Lagrangian of a charged particle in the electromagnetic field. Okay. Where T will be half m v square. This is x dot square y dot square plus z dot square. So your Lagrangian is half m x dot square y dot square z dot square times this you can write v dot a. V dot a will have so your final Lagrangian, let me write half this, then after that I'll stop, x dot square y dot square z dot square, then minus q, then phi has nothing to do, then 1 over c x dot a x plus y dot a y plus z dot a z. So this is your Lagrangian of a charged particle in the electromagnetic field. In next class, I don't know, in next Thursday, maybe holiday. So after the Deepavali, when we come back, then we will play with this Lagrangian and we'll do a lot of things. We'll calculate, we'll consider example and gauge transformation, etc. Okay. Okay. So any question? I'll stop here. I'm taking a few minutes more. Yeah. Those who have class can immediately leave. Those who want to ask some question, you can. I can wait for a couple of minutes for to answer your question.